Welcome to Definite Integrals, Part 1, Trapezoidal Rule. Because the Riemann sums, whether it's the left hand, the right hand, or the midpoint, aren't the best approximations, mathematicians came up with the trapezoidal rule to get a closer approximation. First example, we are going to try to develop the trapezoidal rule and from there use it to approximate the area under curves. So here we are. My first example, use the following example to help formulate the trapezoidal rule. Approximate the area under e to the x on -1, 1 at interval using 4 subintervals. First of all, before we can move on, you have to tell me how to find the area of a trapezoid. You got 3 seconds. 3, 2, 1. It's 1/2 times the height of the trapezoid times the sum of the bases. So, looking at this beautiful trap, we've got 1, 2, 3, 4 trapezoids. Alright? The height is actually the D. And just like a Riemann sum, we need to find that D. So, D equals B minus A all over N. So D equals 1 minus a -1 all over 4. So the D is 1/2. And that will be the height of each one of these trapezoids. The height is, see, all these trapezoids are laying down on their height. Alright, so we have 4 trapezoids. So, area of the first trapezoid, 1 times 1/2. The bases are e to the -1 and e to the -1/2. Second trapezoid, the base is e to the -1/2 and e to the 0. On the third trapezoid, the bases are e to the 0 and e to the 1/2. And on the fourth trapezoid, the bases are e to the 1/2 and e to the 1. Okay, notice that 1/2 times 1/2 is in each one of these terms. So what I did is I moved that out front. So 1/2 times 1/2. And then these terms are left as a summation, but notice we got quite a bit of duplication going on. You got 2 e to the 1/2, you got 2 e to the 0s, and you got 2 e to the 1/2. So, when the subintervals are all equal, the middle bases are duplicated, so they're each times twice, and the bases on the end, there's only one of those. So the formula is right here. 1/2 D, first base plus 2 times second base plus 2 times third base all the way up to the last base. And these bases are f of x's. Each one of those is an f of x. So when we do that, our approximation, by figuring out what this is right here, 2.39917, and the real thing, if we actually integrated, 2.35050, that's about 4/100ths off. It's a pretty good approximation. Alright. Let's move on to the next one. Use the trapezoidal rule to approximate the area on 710 using 3 sub-equal intervals. So 10 minus 7 over 3. So D equals 1. Well, I already did that. Sorry about that. So 1/2 times 1, because D was equal to 1. Okay. E to the square root of 7 plus 2 times the square e to the square root of 8 plus 2 times e to the square root of 9, or 2e to the third plus e to the root 10. So our approximation was 55.86355, and if we did the actual, pretty doggone close. It's a trapezoidal approximation. Alright, next one. Use the trapezoidal rule to approximate the area on 0 to 3 using 6 subintervals. Alright, so what is D? 3 minus 0 all over 6. D equals 1/2. Alright, so we're going to use this one once. We're going to use this one twice. We're going to use this one twice. We're going to use this one twice. This one twice. This one twice. And this one we will use just once, because those are the ones on the end. And that's what I have written down there. So our approximation is 14. Alright, this one I want you to do on your own. I'm not going to give you any, I'm going to give you some time to work on it, and then I will make sure you check your work. Alright, so look at the subinterval, pay attention to it. I'd like you to go ahead and pause this video, find D, use the correct numbers, and then go ahead and come back. Alright, so go ahead and pause and work on setting it up on your own. Okay, hopefully you actually did what I asked you to do. So I got my D to be 1, so 1/2 times 1. Alright, f of 2, because that's the end base. 2 times f of 3, plus 2 times f of 4, plus f of 5. So 1/2 of 1.93, I got 0.965. And now I've got one more for you that is not of equal subintervals. When that happens, what you're going to do is you are just going to add up several different trapezoids together as they work out. Alright, so use the trapezoidal rule to approximate the area under, it shouldn't be on, it should be under, no, on that interval. That's right, okay. So, our first trapezoid, what is the height of the first trapezoid? 2. And the bases are 5 and 6. The second trapezoid has a height of 4. The third trapezoid has a height of 1, and the bases are 3 and 4. And the last trapezoid has a height of 7, and the bases are 4 and 8. I'm gonna pause it and let you pause it and see if you can get it set up. Okay, so hopefully you paused it and tried to set up those 4 trapezoids. Right there they are. 1/2 times the height 2 times the sum of the bases, plus 1/2 times 4 the height times the sum of the bases. 1/2 the height 1 times the sum of the bases. and 1/2 the height 7 times the sum of the bases, and that ends up being 74.5 for our approximation. This does conclude definite integrals part 1, the trapezoidal rule.